Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the JWT attacks module titled JWT Authentication Bypass via Algorithm Confusion. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on the JWT module and go to lab number 7 titled JWT Authentication Bypass via Algorithm Confusion. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. It uses a robust RSA key pair to sign and verify tokens. However, due to implementation flaws, this mechanism is vulnerable to algorithm confusion attacks. To solve the lab, first obtain the server's public key. This is exposed via a standard endpoint. Use this key to sign a modified session token that gives you access to the admin panel at /admin, then delete the user Carlos. You can log into your own account using the following credentials, and we're given credentials of a regular user account. Alright, let's go down and access the lab. Right click and open a new tab. Alright, so notice over here we're using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. We will be using the JWT editor extension just like we did with previous labs, so if you do not have it installed, make sure that you install it through the extensions tab. Okay, the first thing we're going to do is log in with the regular account credentials that we were given. So the password was Peter, hit login, and right away you notice that the requests are in the color green, and that's because the JWT editor extension is noticing that the request or the response contains a JSON web token. So if we click on the first green request over here, and let's close this off to make more space, you could see it's supposed to request to the login endpoint. It takes in a CSRF token, a username, and a password as parameters. It checks in the backend if the username and password are correct. If they are, it redirects the user to their account page, and it sets a cookie in the user's browser in a cookie called session, and the cookie contains a JSON web token over here. You know that it's a JSON web token based on the first few characters over here. And then you could go to the JSON Web Token tab to see the decoded version of the token. So what we're going to do is we're going to go to the My Account page and send that request to Repeater and work from Repeater. So let's send this to Repeater. Go to Repeater over here, close this off, and move this over here. All right, so in the previous labs, we talked about different test cases that you could apply to test for implementation flaws in JSON web tokens that could potentially lead to vulnerabilities that allow you to compromise any account on the application. We're going to assume that we tested all 6 use cases and they did not work. And so today we're going to learn about a new use case. And for this one, we're going to check if the application is vulnerable to algorithm confusion. Now, we already learned about this type of attack in the theory video, but just to refresh your memory, algorithm confusion, or also known as key confusion attacks, is a type of attack where you force the server to verify the signature of the JSON web token using a different algorithm than the one used by the developers. So you could see over here in the JSON Web Token tab, the developer is using an RSA algorithm to sign and verify the JSON Web Token. Now, algorithm confusion is a type of attack where you force the server to verify the signature of the JSON Web Token using a different algorithm than the one used by the developers. To properly understand this, you need to understand the 2 types of algorithms that you could use to sign tokens. The first one is symmetric algorithms, or also called private key encryption or signing algorithms. This is where one key is used to both sign and verify the signature of the token. The second type of signing algorithms is asymmetric or public key algorithms. So asymmetric algorithms, that's where you have two keys. One of them is used to sign the token. This is known as the private key, and it should not be accessible to anyone in the public, so it should only be accessible to the application developers. And then you have another key that is used to verify the signature of the token. Now, this key is known as the public key, and it's not meant to be a secret. And so you'll see sometimes applications actually expose this public key on standard endpoints because it's not really meant to be a secret. The private key is meant to be kept as a secret. Now, algorithm confusion attacks arise when you're using asymmetric signing algorithms such as RSA, which we could see over here. The application is using an asymmetric algorithm. And for this attack to work, there needs to be an implementation flaw where the developer doesn't properly check if the algorithm that is given in the ALK parameter is actually the one that is used by the backend to sign the token. So the way the attack would work is essentially you confuse the server and get it to use a symmetric algorithm where the key that is used to sign and verify the token is the public key that is available for everyone. And that's exactly what we're going to do. The first thing we're going to do is change the subject to administrator because we're trying to access the admin panel. So let's say administrator, and we'll change the directory as well to the admin panel. Next, we're going to change the algorithm to HS256, which stands for HMAC and SHA-256. This is a private key or symmetric algorithm where one key is used to both sign and verify the token. So now we know that the verification of the token in the backend is using the public key. And so what we're going to try to do with this type of attack is sign the token using the public key, change the algorithm to symmetric encryption just like we did over here, and then hopefully if there is an implementation flaw where the server blindly trusts what's in the ALK parameter over here, it'll see that it's using symmetric encryption, it'll take the key that is in the backend, which is the public key, and it'll verify the token using the public key. And since we signed our token using the public key, the verification should pass. Now, of course, to do this type of attack, we need to actually find the public key before we sign the token. And since it's meant to be public, like I said, some servers actually expose the public key on standard endpoints, like the JWT s.json endpoint. So what I'm going to do is go back to proxy and send another request to repeater. And go over here and see if we have access to the jwks.json endpoint. And let's close this off so we have more space. Hit send. And we do. So you could do this in the browser as well. Let's just add it over here. Hit enter, and you could see over here the application actually exposes the public key. Again, this in itself is not a vulnerability because the public key is not meant to be private. And so the vulnerability, if this attack actually works, the vulnerability over here is the fact that the developer is blindly trusting the value of the alg parameter or the algorithm parameter. And so when we do change it to symmetric encryption, the server actually uses a symmetric algorithm instead of the asymmetric algorithm, which was originally set for the application. And so let's test this out. let's copy everything that is in the key array. And you need to make sure that you only copy that portion. You don't actually copy any extra spaces or the attack would not work. Click on copy. Now we need to sign our token, so we're going to use the JWT tab for that. I'm going to remove all the unused keys that were generated from previous sessions. So let's delete that. Hit yes. And then we're going to click on new RSA key. And then we're going to paste that JWK that we just copied right over here and click OK to save it. And then we're going to right click and copy the public key as spam. And then we're going to go to decoder over here and encode it because we do need it in an encoded format in order to add it as a symmetric key, which we'll generate in a bit. So again, make sure you don't have any extra spaces. And then we're going to click on encode as base64 and just copy the string right over here. So this is going to be used as our symmetric key. Let's go back to JWT extension, click on new symmetric key, click on generate, and in the K parameter, add our symmetric key, which is really the base64 encoded public key. Click OK, and then go back to repeater. Now in repeater over here, again, we changed the subject to administrator. We changed the algorithm to a symmetric algorithm. Now all we need to do is sign the token with the public key. So click on sign, and we're using the symmetric encryption. Click OK. Go back to raw. If we did everything correctly and the application is actually vulnerable, we should be able to access the admin panel. So click send, and we get a 200 OK. This is already a good sign. If we render, you could see we've got the admin panel and we have the ability to delete users. So the application was definitely vulnerable to algorithm confusion attacks. So to complete the lab, we need to delete the user Carlos. Let's go back to the lab over here so we could actually see the message once we complete it. Let's search for Carlos so that we could get the path to delete the Carlos user. Let's copy that, put it in here. And again, the reason this is working is because when the application receives this token over here, it sees that the algorithm is symmetric encryption. So it extracts the key that it has in the backend, which is the public key, and it uses it to verify the token. Now we signed our JSON web token with the public key, and so the verification step is going to pass, and it'll allow us to access the admin panel. Hit send, and it should delete the user, and it did. So you could see over here, congratulations, you solved the lab, and if you render over here, the user Carlos is no longer available. All right, so we successfully completed the exercise by exploiting the JSON Web Token vulnerability. In the next lab, we'll look at another use case that you could test for when looking for security flaws in JSON Web Tokens.